In this lesson, we're going to look at our first code example, which you see on the screen is one of my working files. This one is called firstexample.txt. We're looking at it in the Emacs editor, and it's just a quick inventory of what's required for the example. So on the service side, which is where we're going to focus to begin, we need to write the service and then publish it. The service itself is written basically in three pieces. There's a JSP script, Java Server Pages, and then there are two back-end Java beans, so-called POJOs, plain old Java objects. For publication, I'm going to use Tomcat, which is a Java-based web server. Some of you may have used that before. You see the URL on the screen where it can be downloaded and easily installed. We'll go into those details a bit later. Now, on the client side, it's a bit trickier. In real life, we'd want to write a client in some language, but for testing purposes, the curl utility, you see the URL for it, is really convenient. Curl is available on all platforms, and it's possible if you have a Unix-type system that it's installed already. So, without any further ado, let's take a look at the code, in particular at the JSP page. So I'm opening up now another one of the working files. This is called predictions.jsp, and I'm going to go over it in some detail. So in the comments at the top, I indicate basically how this is going to work. So if you look at this line, a client is going to hit the JSP script, which is in effect the front end of the web service. And the JSP script is going to communicate with the back-end Java Bean code in order to get the data to send back to the client. The service itself is fairly straightforward. When a client hits the service, the client receives a list of what I'm going to call Sage corporate predictions. We'll see these in the flesh shortly. In order to test the service, I have two curl commands. One of them is here. That issues a GET request, which I'm going to honor. And the second is going to issue a POST request, which the server is going to refuse. So let's jump into the details. This very first line uses a customized JSP tag called useBean, and it identifies the object reference that I'm going to use in the code. I call this preds, short of course for predictions. The supporting code is a class called predictions, as you can see on the next line. And the class is predictions as well. By the way, I could drop either type or class. I don't need both, but I've included both. A little further down, at this line, we begin what JSP folks call a scriptlet, embedded Java code. So this will look familiar, even if you've not seen JSP before. It's standard Java, and it relies on a number of so-called implicit object references, which my code picks up by way of inheritance. So in this case, I have an object reference called request. That's the incoming HTTP request. Another called response. That basically is a channel back to the client so I can communicate. The application is a little bit tricky. I'm just going to give it a name and explain it later. It's the servlet context. It allows me, in effect, to talk to Tomcat. And finally, the last implicit object reference is called out. That's the output stream. That's where I'm going to write the XML document that I'm going to send back to the client. So the logic is pretty straightforward. The first thing the code does is to filter on the HTTP request. So you see request get method at line 2. This is going to return a string. At line 3, I then check to see that this string is get. Uppercase, lowercase, mixed case, doesn't matter, as long as the request is a GET request. If it isn't, I'm going to generate a so-called status code, in this case 405, and in HTTP speak, 405 stands for method not allowed. So basically, my code is saying a GET request is okay, anything else is not okay, you're going to get an error. And you can see at line 4 a customized error. So response send error sends back the appropriate status code and then a little customized string message. If everything is okay, the else clause kicks in, and at line 5, the code makes use of the PREDS object reference, that's the one all the way back from line 1, in order to set things up so that it can get the data required. The data, again, consists of a list of corporate predictions. We'll see what these are momentarily. And then finally, the real action is in line 6. The PREDS object reference is used to get the XML document, and out print line sends that document back to the client. At this point, business is over. We've completed the transaction with the client, and the script simply exits. Now, in order to show how this works, let me bring up a terminal window. So I'm going to close the editor, and you can see a curl command up there at the top. I'm simply going to execute this. It runs, and let me highlight what's important. Devin Blanda is a corporate officer who makes this prediction above. So basically, Devin is the who, and this prediction is the what. As you can see at the line slightly above, you see void index 30. Let me highlight that. This indicates that the underlying predictions might have been generated from an array, which is exactly the case. There are 32 of them in all, and Devin's is just one of these. So basically, what the service has sent back to me, the client, is this XML document that represents all of the predictions. Let me show you what happens if I try to change this curl example to something else. What I'd like to do instead, and I'll clear the screen to make it more visible, is issue some other type of request. In this case, let's go for a put request. Post or anything else would do. Put is basically an edit request. If I do that, I basically get back an error page. So in this case, you can see the status code is 405. That's the method not allowed. And then hidden in this little HTML error document is my customized string saying get requests only are required. As proof of concept, then, we see that the service accepts get requests and rejects non-get requests. Those are the key points. So let me summarize. The service has been published with Tomcat, and we've tested it with 2 curl commands. So those curl commands are acting in effect as client requests. What we've not looked at is the back-end Java code, and we're going to do that after taking a brief pause.